Do you hear us? Yes, now. Okay, perfect. Welcome to our presentation. I don't know. Okay, you already have seen the presentation from Stratasys here now, and we are digging in the same corner, let's say something like this, because we are also working on textiles, with textiles in combination with 3D printing. And what we want to do today is just to give you an impression what textile means. You already have seen that it's, of course, possible to do 3D printings onto textiles for fashion applications, and but textile is much more. And the second part from my colleague will be a machinery, a multi-modular machinery for doing these kind of prints. Okay, we are from the STFI, Saxon Textile Research Institute, and from the TITV. Yeah, both are research institutes for textiles and for technical textiles and smart textiles applications. So, if you think of textiles, you maybe think like having clothes on, and this is, yeah, the fashion purpose. But textile is much more. If you are here in the personal protective equipment, also something everybody or somebody has on, and it's on the human, but you have a certain function in behind. You have textiles in fiber-reinforced plastics. You can do optical illumination with textiles. You can do medical textiles with certain kind of functions. You put on, or you are able to put on sensoric materials onto textiles by embroidery. You have acoustic textiles. You have cargo nets, ropes, and so on. And also a very interesting topic is everything going on into the earth or down into the earth. So geotextiles also in really large areas, agricultural textiles, textile reinforced concrete, so it means architecture, filter applications, also textiles, yeah. And interiors, automotive interiors. This is also, which is already addressed by Stratasys in the talk before. Yes, but as you see, textile is much more than clothing. Okay? And even at all, textile goes to space somehow. Yeah? Okay, so normally we have here there a triangle. So we want to have a textile with a certain functionality. And if you need, or if you have a certain kind of functionality, we have, yes, a competition with certain kind of textile properties. Let's say something like this. And of course, we have the processes, how to process the textile to achieve the function. And we start here with some functionalities, classical functionalities on a textile like hydrophobication, oleophobication, flame retardancy, anti-statics, certain kind of stiffening or reinforcement. If you go into the part of sensorics, you have conductivities, sensitivities, thermoelectrical, chemical. If you go into the personal protective equipment, you need a certain kind of resistance against wear, stabbing, or cutting, and so on. And if you know that you have certain kind of functionalities and you want to have a textile which is able to do this like this, you have, or you will get a problem with the properties of the textile. What means with their breathability, if you have a stack of multi-layer stack of textiles and membranes, with flexibility, if you have a rigid coating onto it, it's nothing flexible purpose there or property there. You get a loss of stretchability and so on. And last but not least, the textile industry, especially here in Europe, needs a change, even of the whole world. If you have the process here, the goal is to do it more on demand. It's, You can work on demand, produce on demand, what means individualization is possible, small batch sizes, and the material you put onto the textile is in a resource-efficient way. So that means additive manufacturing is quite interesting for the textile industry. And we are working with a lot of different technologies to put materials in a patterned way onto the textile. And of course, we have the whole additive part. So it means we are applying printing processes in a two-dimensional way by valve jets, normal inkjet printing, spray-on-demand printing, dispensing, and so on. And also 3D printing methods like the fused layer modeling and also the dispensing itself. The colleagues from TITV, they also apply powder materials. It's also quite interesting. Additionally, we are able to apply textile methods like embroidery and laser patterning for subtractive purposes. As you see, there are many different methods to apply material onto the textile, and yeah, what we can do with it. At the moment, here are some applications we are working on in different research projects. Here are some examples for stiffening for architecture purposes. If you print a thermoplastic material onto the textile, you also have the ability to do a thermoforming afterwards, also quite interesting. You can do something like these kind of 4D printings, decoration, single spots for patterned functional coatings against wear, classical hydrophobication purposes, but also, yes, here some marker material for targeting and triggering of textiles. Yes, that's it from my side, because now I guess you have more an idea what textile means itself, and what we are working with different tools, and these kind of tools is possible to join them into one machine.
Okay.
And so now this is your turn. This screen.
Thank you, Frank. The main research of the TITV is to bring conductive structures onto textiles, so smart textiles we call it. And for this purpose, we have this kind of machine. It's our universal tool unit. It's, in fact, a classical CNC machine, which is reworked for textiles. So we have a tool head with 3 simultaneous tools can be driven. Also, we have a large building room, and we can have much power to bring structures on these textiles fast. So what tools do we have? We have some textile spreaders to bring the textile plane onto the table of the machine on both sides, so we can process from roll to roll. Also, our tool head, in this configuration, we have an IR camera on the left side, in the middle a laser, and on the right side there's a dispenser from Viscotech, the Vipro head, that we can bring viscosity fluids onto textiles. This is not the only configuration. This mission is built that it's modular. We can bring other tools like FDM printing or what you can imagine to this machine. Also, we have an industrial inkjet, and you see much more space for future projects where you use other tools. So now let's think about a process. You want to bring some structures to a part of textile. So we have so-called embroidery frames, which are standard in the textile industry. What is this picture shows? And we will get in the near future a table plate where we can screw down these frames. And also we can process from roll to roll and fasten the the fabric onto these frames. After that, we can cut out it with a laser. Yes, it's subtractive manufacturing, but you can also use it for other kind of stuff like hardening resin, or to fix some powders of metal, or what you can imagine to do with laser. Also, after this, we can loose the screws from the embroidery frame and bring it to our embroidery machine to bring up there some conductive threads, so we can after that solder some LEDs or touch sensors or something like that to it. After this process, we can do a quality check with our IR camera. So we can put some current onto the structures, and everyone knows if you get current on a wire, it warms up. So we can detect hot spots and cold spots to ensure there's no short circuit, or we can prove that our structure is working like expected. If there's some short circuit in there, or like the machinery before can't handle some separation, so we can separate it after that with the laser and can split up some circuits from another. Or we can mark with the inkjet some failure parts of these circuits. Or after that, the solder joints can be insulated with the dispenser. That's only one possibility what we can do. But what are the challenges of these? So we have to figure out how we can use all the tools simultaneously. How do we detect failures, and we can repair them. So we need some sort of API and external program which can analyze our IR cameras, the footage of the IR camera, and bring it to the machine. Also, we have different kind of processes here. So we have subtractive with the laser, which means we get G-code from a classical CAM software, or the dispenser is a classical slicer where we can get our G-code from. So we have to merge all these kind of G-code together and bring it to work. Also, the main challenge is how to automatize these kind of tools together to bring a product which does not need so many manual attachments to it. So, is your interest around it? So feel free to contact us. We are every time interested in cooperatives to bring a knowledge transfer from the research to the industry. Thank you.
Okay. Thank you. What we want to do is we want to invite you for tomorrow. It's in German, I'm sorry. But if you like, you can join us for tomorrow for the Symposium Additive Fertigung in der Textilindustrie. It's right here in the Portalhaus. It's over there. Room Frequenz 2. And if you like, you can join us. Thank you very much.
Thank you.
Thank you very much. Well, time for a quick question, if anybody has any, or where can they find you for questions after this? Will you be around in the hall?
Around here tomorrow at the symposium.
And at the summit. Okay. Yeah, so take down the details and join them if you would like. Thank you very much, gentlemen.
Okay, thank you.
Thank you.
Bye.